Hello everyone, my name is Pawan Kumar Thakad and today I am going to teach you very important topic of calculus named as functions. So in a 2-day class, first of all I will give you introduction about Cartesian product and relations. After that we will define the concept of functions with the help of Cartesian product and relations. So start with Cartesian product. Let's start product. Let X and Y be two non-empty sets, then the Cartesian product X cross Y is be the set of all order pair X comma Y such that X belongs to X and Y belongs to Y. Or define Y the Cartesian product X cross Y and the set called Cartesian product. So I will explain Y Venn diagram. Let X a Venn diagram here 1, 2, 3. Let Y is equals to 1, 2. I will map 1 to 1 the all element of X joined with all element Y. The collection of all order pair 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2, 3 comma 1, 3 comma 2. This is a Cartesian product of X and Y. So now if if I find the number of subset of X cross Y, so the general formula of this finding the subset of X cross Y is 2 to power mn. If the set X has m element and the set n Y has n element, then the number of element in X cross Y is mn. हम the seen that हमने ऊपर देखा था कि X has 3 element, Y has 2 element. The total element of X cross Y is 6. So 1, 2, 3, 4, 5, 6. The total number of subset of X cross Y is 2 to power mn. So now the total number of subset in this X cross Y is 2 to power 6. So relation, what is a relation? A relation from the non-empty set X to a non-empty set Y is a subset of the Cartesian product. The, the any point 1 comma 2 is subset of X cross Y. This is a relation 1 related to 2. One if 1 comma 2, 2 comma 1, this is also relation. If 1, 2, 3, 1, 2, if I will join with 1 to 1, 2 to 2, this is also relation. If I will going joined with 1, This is also relation. Every subset of a Cartesian product is a relations. Now defining functions. The function is a special type of relation. कुछ condition होती है उसके ऊपर, तो the definition क्या है function. So definition of functions. F from x to y be a function. The every element of x only one image in y. Two necessary conditions होती है. So the every element of x must be associated. तो सारे एलिमेंट है उन मैप होने चाहिए कहीं ना कहीं. So if I will choose 1, 2, 3, A, B, C, this is not a function. Function. This is not a function. But A, B, C, मैं this is a function. If 1, 2, 3, A, B, C, this is also not a function. This is not a function. This is not a function. The function is a special type of relation. The the vertical line test of check this is a function or not. If draw a line parallel to y-axis, or this line is cut exactly 1 point, then this is a function. But this is cut more than 1 point, then this is not a function. If I will choose the function y is to x square, then I will draw the line parallel to y-axis. This is cut exactly 1 point. I will parallel to line every line parallel to y-axis cut exactly 1 point. If I will choose the function like this and draw the line parallel to y-axis, that this is cut 2 times. So this is not a function. This is not a function. This is a function. So domain, codomain or range. Let f x to y भी कोई functions है, तो उसकी domain होगी the set of all input element in x, तो पूरा x हो जाएगा. Codomain the set of all possible outcome element in set y, तो पूरा y हो जाएगा. The range the set of all actual image of the element of x, से range बोले. This is called range. Range is a subset of codomain. I will explain by example. One, two, This is domain. This is range. uh, This is codomain. The range, clearly range is subset of codomain. Codomain. So rule of finding the domain. So first of all, I will my function is must be defined in the R. Suppose root of fx is defined if fx is must be greater or equal to 0. If my function is 1 upon g of x is defined if this is never be 0 or any point of x. If my root is denominator, if this function is defined if this is strictly 0, or the algebra of a function from fx or gx, sum of the two functions. The domain is if domain of fx is d1, the domain of gx is d2, then the domain of f plus g is d1 intersection d2. To find the domain of this function, my function is root of x square minus 3x plus 2. So I will see that this part is must be greater equal to 0. As 3x plus 2 greater equal to 0. This is a quadratic equation. Solve this equation. X minus 2, x minus 1 greater equal to 0. Draw the real line. Plot the point 1, 2. This part is positive, this part negative, this part positive. So हमें चाहिए greater equal to 0. तो this part or this part. The domain of this function is x belongs to minus infinity to 1 closure union 2 to infinity. This is a domain of this function. So now explain next example. Find the domain of the function is the denominator root of the denominator. So this part must be strictly 0. So mod of x minus x is strictly 0. Mod of x is strictly x. If my x is greater or equal to 0, then mod x greater or equal to x mod x is x is greater or equal to x. This is a contradict क्योंकि 5 greater or equal to 5 नहीं होता. If my x is less than 0, then mod x is minus x greater or equal to x. Minus 2x is less than 0. So x is less than 0. The x belongs to minus infinity to 0. The domain of this function is x belongs to minus infinity to 0. So, so consider this function. fx equals to g of x plus h of x. G of x, x square minus 3x minus 4, x belongs to minus into to close one union 2 to infinity, or x belongs to minus infinity to 0. The domain of fx, if the domain is, let d1 is equal d2 है, the domain of fx is intersection of d1 intersection d2. So the intersection of domain of gx and hx is minus infinity to 0. So the domain of fx is minus infinity to open 0. We'll explain relations, functions, graph check of this is functions or not, or domain rule. Thank you.